so that depending on what we write down, you can learn. So when is like the next assessment or test or whatever?
I already did a Siavula assignment. I did quite well on that one. So
Ooh, yeah, fancy.
What do you mean?
Fancy, man. What do you mean? What?
What do you mean
Like,
fancy?
how? It's just a reaction, ma'am. You know, it's a positive reaction to a positive comment. You know, it's just one of those things. You see, that's a fancy. You see, that's a fancy mark. You see, that's a fancy mark.
Yeah.
Yeah, you know, fancy marks, fancy people.
A test on Monday.
What is it on?
About. It's based, you see the stuff that I'm asking you right now. Stuff that I don't understand that are going to be in the test. The rest of the stuff I understand. It's just this that I don't understand.
Oh, okay. I see. Let's look at it then. It says list the possible values of a for which the square root of a is between 6 and 7. So, and then they said a is an element of n. So the idea is you just want to keep in mind that in terms of numbers, right? This is the basic idea. Always think of it as you have like a pool. you for example, think of Earth, right? Anga, you have Earth. Oh no, let's take it this way. Anga, you have, let's say, your house, right? Your house is maybe somewhere in Gauteng, right? And then so this is your house, right? This house is in Gauteng. And then this Gauteng is in South Africa, right? And then this South Africa is in Africa. And then we can, right? Africa is on Earth. And then Earth is in the solar system. And then the solar system is in the galaxy. And then if you want, you can say maybe this galaxy is in the universe. You see? Universe. Oh, I messed up there. Universe, you see? So this big idea here is how numbers work, right? So if you think of what we mentioned here, the big thing here is the universe, right? And then inside the universe, you have galaxies. And then in galaxies, you have, I don't know, solar systems maybe, or whatever they call them. And then inside those solar systems, you have planets. You see, planets. And then inside planets, we now have all these other things, right? We have continents. And then in continents, we have countries. And then in countries, we have provinces. And then in provinces, we have houses, you know? So that basic idea of knowing that most of the time you have one big thing, and then in that big thing, there's everything else. That's how the number system works. So with the number system, right, you can think of the universe as real numbers. So when we say real numbers, we're talking about every number that you can possibly think of, every single number in the whole existence of numbers. That's what real numbers are. So once you think of real numbers basically are numbers from negative infinity all the way to positive infinity, you see, without any restrictions. This is absolutely every number that there is. The moment you start adding restrictions, right, it means that you start classifying certain numbers into certain categories, you see. The same way how, for example, in the universe, you have, you know, different this, different that, different this, different that. So with real numbers, let me just list a few other types of numbers that you have. So within real numbers, right, we have the following. We have integers. Integers, as we know, these are complete values, complete numbers. You see? And these can be both positive or negative. You get? Are you still there?
Yes.
Perfect. So those are integers, right? It's complete values, both positive and negative. When we say complete values, we know they have no decimals, you see. So that's one category of numbers that are within real numbers. So another category of numbers that we have is natural numbers. Or let's start with whole numbers. Whole numbers. You see, whole numbers, the symbol there, or let's actually start with, let's also be mentioning symbols as well going along. So real numbers, we already know it's this symbol, it's like an R. Integers, we know it's like a Z. And then whole numbers, we know it's an N, but then it has a 0. This 0 is the one that reminds you that whole numbers start from 1. I mean, start from 0, 0, 1, 2, going on. So whole numbers are also complete numbers starting from 0, you see, and only positive numbers. You see, that's what whole numbers are. So obviously you can already tell that inside real numbers, you have integers. And then inside integers, you have whole numbers. You see, because whole numbers are also integers, but then only one starting from 0 going onwards. And then funny enough, inside whole numbers, you have natural numbers. Natural numbers. You see, and natural numbers have the symbol, it's like an N as well, but then it has nothing here. But the natural numbers start from 1. Start from 1. Start from 1, and then only complete values. Only complete values. And when I say only complete values, I mean that they have no decimals, you see. So it's like 1, 2, 3, 4, going on and on and on, you see. So those are natural numbers, you see. So with all this being said, right, we also have a specific, we also have another category of numbers, which are called rational numbers. Rational numbers. So rational numbers, right, the funny thing is, the easiest way to say it is all natural. So with rational numbers, right, you have in there natural numbers, you have in there whole numbers, and you have in there integers. You see, all natural numbers are also rational. All whole numbers are also rational. All integers are also rational. In addition to these, another set of rational numbers is basically, let me put here, let me make it in simple English. Let's write here normal looking numbers, for lack of a fancy word, because we don't want to use any fancy words or any fancy descriptions. So when I say normal looking numbers, I'm basically referring to, let's say here, example, fractions. You see, so if something can be written as a fraction, like let's say, for example, here 1/2, this is rational. It qualifies as a rational number. If you have, let's say, 1/105/83, this is a rational number. You see, it can be written in a normal way, you know. We can think of any other random value. Let's say square root of 16. The issue is square root of 16 is a square number. 16 is a square number, so this is just a 4. So square root of 16 is a 4, of which that's still just a rational number. So I put this there to show that it's not just the square root that says something is irrational. No, this, you always have to work it out. Square root of 16 gives you a 4, and then now you can determine whether it's rational. And we said for you to determine whether something is rational, we said just ask yourself, is it like a normal looking number? Is it like a fraction? You know, is it like an integer? Is it like a whole number? Is it like a natural number? As long as it looks normal and it looks okay to like write out and to like work with when you're doing math, then it's a rational number. So to give better understanding, let's talk about the irrational numbers. So when you think of irrational numbers, then the easiest thing you can do for yourself is you can say here weird looking numbers. You see, weird looking numbers when let's just say weird looking numbers. Oh, let me just write here a bit better. You see, weird looking numbers like that. You see, it's just weird looking numbers. So an example of those is something like pi. The reason why this is a weird looking number is, I mean, look, 3.14, blah, 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 blah. It's weird, you know? It just goes on forever. Of course, that's weird. So that's why it's irrational. We can classify it as irrational. And then things like, let's say, square root of 3. Square root of 3, remember, it is basically 1 point something, 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 something. Let's just check what it is in the calculator. In the calculator, if we put in the square root of 3, let us see what we are getting. Let me just get my calculator here so that we can see what this is in the calculator. So square root of 3 is the number 1.73, and it's like 2 going on and on. You see, it's a weird number. It's a weird looking number. So that's why we regard it as irrational. And then if we can think of like another example, I mean, we can have there, let's say, square root of 3 with a 2 here over, let's say, I mean, like a 5 there, you know. This number here, if you put it in your calculator, right? I mean, let's maybe not, let's leave something like this out, because I think this might get a bit confusing if we start to become too fancy. But then that's the idea. You see, inside real numbers, you have everything else. You see, because inside real numbers, right, some of them are integers, of which we said integers, they are just complete numbers, both positive and negative. So it's numbers like -3, -2, -1, 0, 1, 2, 3, going on and on and on, all the way from negative infinity all the way to positive infinity, but only complete values. Whole numbers, we said, they only start from the 0 going onwards to the right. Natural numbers, we said, they only start from 1 going to the right. And then we said what? We said what you may call rational numbers. You have natural numbers in there, you have whole numbers in there, you have integers in there, and they're just normal looking numbers. For example, fractions, you see 1/2, something like this here, square root of 16, that's just a 4. Those are rational numbers. And then now we said irrational numbers, they're just weird looking values. You know, they usually have extended decimals. Let's say here, you usually have a lot of decimals. You see, like that. Those are irrational numbers. So obviously, all those are inside real numbers, because real numbers is like every single number ever. You know, that's what real numbers are. We can, let me put it here also. You see, every number that exists, every number that exists. So this is absolutely everything. Rational numbers, irrational numbers, natural numbers, all the shebang, you know. That's what real numbers are. So inside these real numbers, some of them are integers, some of them are whole numbers, some of them are natural numbers, some of them are rational, some of them are irrational. You see? So that's the idea behind what we need to know before we even tackle any of this. So does this that we have mentioned right now make sense?
It does.
Nice, nice. We love to see it. We love to see it. So anyways, with all that we have mentioned, right, the question that we have to answer there is going to make a bit more sense. So for example, it says list the possible values of A, right? The possible values of A for which square root of A is between 6 and 7. Okay, so if square root of A is between 6 and 7, you can always just reverse engineer that question, you know, because let's look at it this way. They said, let me actually copy this so we don't keep scrolling back upwards. So what I can also say is whenever you're going to work with questions, right, Never think that you only need to read the question once. No, you can read the question as many times as you feel you need to, or rather, always read it as many times as you need to, until you understand what they want you to do. So we say it here. They say it here. List the possible values of a for which the square root of a is between 6 and 7. So this kind of a question, you can almost work it out, using trial and error. Because let's test out square root of 16. Square root of 16 is a 4. You see, so if a is a 16, the square root of a is a 4. So this doesn't work. Let me repeat. They said list the possible values of a for which the square root of a is between 6 and 7. So let's say here, if a is equal to 16, then we'll have here square root of 16, of which that's a 4. So this does not qualify for the question that they asked us. So we have to keep going. Instead of us picking random numbers for a here, we have to pick square numbers, obviously, because only a square number will give us what you may call. We actually don't need to worry about putting a square number here. We just have to think of slightly higher numbers if we're going to get something that's an answer between 6 and 7. So you could even think to yourself, let me try square root of 49. Square root of 49 is exactly a 7. But then here the question literally says list the possible values of a. So when they say possible values, they're trying to give you the idea that there is quite a lot of them. You see, list the possible values of a for which square root of a is between 6 and 7. So if square root of a is going to be between 6 and 7, this is already telling us that we are going to have like a range of answers, of which our range here, we can see that it's going to end at 49, because square root of 49 gives us the set. Yeah, go on.
So we find the square root of 6 and 7, which is 49 and 36. Then we list the numbers from 36 to 49.
Yes, but we actually don't have to write them all out. All we have to say is that a is between 36 and 40. And the way we do that is we say a is bigger or equal to 36, or a is smaller or equal to 49. So this will be us saying that your value of a is going to be anything between 36 and 49. You see, meaning you're already talking about all those numbers without you needing to like write absolutely all of them. Because remember, you cannot write every single number between 36 and 49. There's just too many. Because between 36 and 49, you have like a bunch of real numbers in there. You have a bunch of rational numbers. You have a bunch of irrational. You have a bunch of integers. So they're just almost like an infinite number of numbers between two values. So this is how you can give your answer. But if you guys have, like, let's say, been working on, let's say, set notation, you can say something like a is an element of 36 until 49. Have you guys been working on anything like this?
Kind of.
Kind of. Okay, so what this means is this is you trying to restrict the value of a to being something between 36 and 49, where these square brackets are saying you will be starting from 36, and 36 forms part of the solutions that you're looking for. And then this square bracket also says you're going to end up at 49, and then 49 you should include it as part of your solutions. If you had used round brackets, what that is saying is your answers are between 36 and 49, but then 36 itself is not part of the answer, and then 49 itself is not part of the answer. You would just be talking about things that are between these numbers without including those numbers themselves if you use the round brackets. You get?
Yep.
Fantastic, fantastic, fantastic. So that's for the first question. The next one, let's see. First day. It says here, list the, oh no, it's the same thing. Oopsie, that was going to be awkward. Oh, where am I now? Where is this thing? Where are we supposed to be? What? Dude, where's this thing? Oh, dang it, dude. We have to go back to what we just did right now. Because here they specifically said A is an element of N. So this is going to restrict our answers. Because now we actually do have to list those numbers. Dang it. So this is saying everything between 36 and 49. But then our question literally only wants us to be mentioning only natural numbers, you see, of which in this case, the only natural numbers we're going to be mentioning are like complete values. So we'll have to say here, this we have to disregard it. This is wrong, this is wrong. Anything between 36 and 49, right? That's a natural number. Remember we said natural numbers, they are just complete values, including one, starting from one. Natural numbers start from one, only complete values. So between 36 and 49, we just want complete values only. So here we can say A is an element of starting from 36, and then we're gonna have 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. There you go. And then you close it off here like that. Do you see?
Yes.
Fantastic, fantastic. So that's how we would answer this question. So yeah, what you said makes all the sense in the world. So yeah, let's go. Away, away. Aya donkey. So we can move on now, eh?
Yes.
Cool stuff, cool stuff, cool stuff. Anyways, let's see here. Copy. Let me paste this thing over here. You're not. Oh, what is this thing doing? Snap. Let me crop this thing and move on to the next one. Okay. So the next one says, find a rational number. Okay, a rational number between a half and a third. So this is the first one. So remember we spoke of rational numbers and we said rational numbers just need to be normal looking numbers. So between a half is like 0.5, right? Until like a third is like 0.33333. But then, I mean, it can be written as a third, so it can be written as a normal looking number. So that's why it's a rational value. So that's why here you see what's important is the wording, how it's just basic. Because you see, to avoid getting confused, here we said that usually has a lot of decimals. You see, the keyword usually already says some do, but they are not irrational. Just like this one. This has many decimals, but then it does not qualify as looking weird. You see, so that's why it's not irrational. It literally is a normal looking number. We said example fractions. So that's why here, this is a rational number, this is a rational number. So between the 0.5 and the third, they want us to find a rational number. I think we should actually swap these two and write the smaller one first and then write the bigger one after, because I think it's going to help us like work out something that looks normal. Do you get?
Yes.
Cool. So between, luckily what you can do here is you can just look at the decimals, you know. So what kind of a decimal do you think we can think of that can be easily written as a normal looking fraction?
One half.
Well, like, yeah, we have 1/2 here already, but between 1/2 and 1/3, what, if you look at the decimals, which decimal can you think of that you think can easily then be written as a normal looking fraction? Because remember here you have 0.3, and then you can think of 0 point something else, and then here you'll have 0.5. Think of like a decimal that if you put it in your calculator, it's going to come out as like a nice looking fraction.
I don't
Because
know.
okay, what about 0.4? Because remember, 0.4 is between 0.333 and 0.5, of which 0.4, if you throw that into your calculator, it's just 2/5. You see?
I see.
Yeah. So using the decimals as like a way to like help you see which fraction you can choose is, yeah, that's the method behind why we want to see the decimals. Because from the decimals, you can already see here, you could just think of 0.3, right? So thinking of something like 0.3, somewhere in the middle, you're gonna get 0.4. And then you get other decimals, right? And then here you have the 0.5. So since they want us to just pick just one, they say they find a rational number between this and this. So this will be a rational number between the third and the half, you see, because we remember we said here a rational number. I feel like I'm going to start sounding like a broken mic now. A rational number will just be normal looking numbers. For example, a fraction. And this is a normal looking fraction, 2/5. So that's that for that one. Moving on to the next one, we're going to use the same idea based on what we did. And when I say using the same idea, I mean always try and see what the decimal number looks like, because the moment you see what the decimal number looks like, you will automatically see which values are like normal to work with. You see, just like here, when we were seeing the decimals, we were then able to say, okay, between this and this, there's a 0.4 somewhere, of which the fraction value, our calculator can then just give us that. With here, let's see here, change style, let's make this white maybe, or not white, let's make it this color. So to start off, we can just check in our calculator, what is square root of 2 anyways, just like to see what that value looks like. Square root of 2 is like 1.1 1.414, and then the square root of 5 there. I think this one is not going to be too difficult. Square root of 5 there is like 2.23 what, you see. So if you're going to find a rational number between square root of 2 and square root of 5, you can just look at the decimals and ask yourself, can you think of a rational number between 1.4 something something and 2 point something something? Can you think of a normal looking number between these two here? Can you?
3?
Is 3 between these two? Because
Or
remember
I
3,
could
remember 3 is after the 2 point whatever.
say 2.
Yes, 100%. You could say 2, because 2 is bigger than this one, and then 2 is smaller than that one. So a rational number between square root of 2 and square root of 5 is 2. You see, because 2 is between these two of them. You get. So that settles that one. The next one, we do exactly the same thing, you see, because remember we said as long as you can see a number as a decimal, it like becomes so simple to like, figure out and everything. So between a pi and 4, I mean, like this one is, we should just not overthink it. Pi is like 3.14 something. And then 4 is 4. So what normal looking number can you think of between 3.14 and 4? Even if it's just a decimal, but it doesn't have something very long after it, that would be good enough.
3.
But then you see 3 is before this one.
3,2?
Yes, that's perfect. 3,2. Because if you put 3,2 in your calculator, it's going to come out as something normal to look at. You see, 3.2. And then this is going to be equal to 16/5, like that. And then that's a rational number between the pi and the 4. Because remember, this qualifies for the simple definition we gave. And our simple definition was normal looking numbers, example, fractions. You see. So That's that for the page that you sent. No, there was something at the bottom, right? But then with what we did now, does all of it make sense, madam?
It does.
Fantastic, fantastic. We are love to see it. Anyways, so let's see. what is next here? So the next thing is, it says find an irrational number. Okay, so this one is going to be super easy now. You see, because I'm like, we have gone through getting a rational number. So in terms of us getting a rational number between these, it was just a matter of us looking for something that was not normal. I mean, that was normal, I mean. So here we're just going to do the opposite, right? I mean, between 2 and 3, oh, these are different values though. But it doesn't matter. Between 2 and 3, right? Can you think of a non-normal looking number between 2 and 3?
Mm, 2.5.
Well, 2.5 is a normal looking number. Like, just think of it. 2.5 is going to give you 5/2. That's nice looking. It's not weird. It doesn't have very long decimals. So the easiest thing you can do for yourself here is think of something that's going to be under a square root, where if you put it in your calculator, it's going to come up with like long decimals. Like, for example, something like square root of 3. Just think of something like square root of 3 and see if it falls between these two. So let's see if square root of 3 falls between these two. Square root of 3. Square root of 3 in your calculator, it's just 1 point something, something, something. So it doesn't qualify because square root of 3 is below 2. Do you see that?
Square root of 7.
Okay, let's try square root of 7. Square root of 7 is, oh yeah, perfect. Square root of 7 is equal to 2.645775131, going on and on. You see, so this is definitely irrational, the square root of 7 there, because look, it just has, you know, this extended decimals there and they just mean nothing. So this is definitely irrational. Irrational, you see, because it qualifies for irrational for our simple definition here. Weird looking numbers, example pi, you know, and you know, usually have a lot of decimals. The next one, we need an irrational number between square root of 3 and square root of 2. So again, all we do is we said, write the numbers as decimals. It will make your life a bit easier, you see. So square root of 2, it's giving us 1.4 something something, 1.414 dot dot dot. And then square root of 3, it is giving us 1.732 blah blah blah, you see. So you just want an irrational number between these two. So obviously if you have like square root of 2 here and square root of 3 there, I mean, you don't even need to overthink this one. You could even just pick from the top of your head just a random number that starts with 1, and instead of it having a 4 immediately, it can even start to have a 5, because it will fall between these two. Because this one has like 1.4, right, and then other values. This one has 1.7 and then other values. So the number you pick here can even just be 1.5, and then you pick just random numbers after it. 3, 8, 1, 6, 2, 1, 5, 3, 8. Just random normal numbers, of which this is irrational. I mean, like, just look at it. It doesn't look normal. It looks weird. It's just odd. You see, it's just like a weird looking number. So do you get it for this question? Why we have picked this number? It's just random. But do you get why we picked it?
The decimal is the square root of 2.5, ne?
Yes, yes. This is square root of 2.5. This number here is square root of 1.73. What? Because
Okay.
you guys use your calculators, right?
We do.
Oh, thank goodness. Oh, I was about to get a heart attack. Anyway, so do you get why we chose this number as the irrational number between these two?
Yes.
Nice, nice. And then last and definitely not least, I guess, is we have between pi and 2 pi. So, I mean, it's the same idea, right? I mean, like pi is the number 3 point, let's see, what is 3.14, blah, 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 blah. So double that is going to be like 6.28, blah, blah, blah. A rational number between here, you can pick one.
Square root of,
Okay, that's an okay way to go.
I'm thinking of one. Ish. The square root of 12.
Let's see, square root of 12. Yeah, square root of 12 works because it's going to be bigger than this and smaller than this. So you could have also even used this as an example to say, you can just pick any number bigger than 4, right? I mean, any number bigger than 3, and then give it a lot of decimals, as long as it's smaller than like 6. So you could pick here, you could have picked like 5 point, and then you just give it a bunch of decimals, 6211943818. I'm just trying to give an idea of how basic it is to determine if something is rational or irrational. You see, you can just think of almost like the English definition of irrational. Something that's like irrational is something that's just like off. You know, it's just weird looking. You see, or it's just weird in a sense. This number here is definitely weird in a sense. You know, it's basically odd. Not let me not say odd, because now it's gonna make it sound like I'm talking about odd and even numbers. No, I'm just trying to say it's a weird thing. So that's why it qualifies as irrational. And we can literally just guess it from the top of our head. But then square root of 12 is also perfect. But then when you see square root of 12 in your calculator, I mean, like, it highlights why it's irrational. This number is literally 3.4, what. You see, it's just decimals that are just randomly going everywhere. So do you get it now?
I do.
Away. Let me just stop this thing, so